This GDC video is going to look at how we can analyze a function graphically using your GDC, okay, in particular focusing on maximum and minimum points. So we're going to start with this function here. It says use the second derivative test to find the x-coordinates of the relative extrema of that function between 0 and 2 pi. Alright, we're just going to get straight into it. So on your GDC, you want to graph the function natural log of x plus sine of x. And what we're going to do is hit enter. But this one specifically asks us to use the second derivative test in order to do that. So of course we could go menu, analyze maximum. Okay, there's one x coordinate, and repeat for all the others. Or we could go menu, trace, graph trace, and it actually will stop on the maximum, the minimum, maximum, so on. But this one, of course, is outside the domain. But we want to use the second derivative test. So one of the things we can do once we've graphed a function is actually graph the derivative of that function. Okay, it will bring up, see the button in red there, it will bring up a menu here, and you can choose ddx. Alright, the variable we've used is x, and we just want to graph the derivative of f1 of x. So there's our first derivative. Okay, now what you can see is the zeros lining up with those turning points. Okay, if we look at the second derivative in the context of this, let me just shift that out of the way, then we have the option of graphing the second derivative, which is this one here. Oops. And again, it's x, and it's the second derivative of f1 of x. Okay, so what this second derivative test is showing us is, first of all, that we have a 0 here. Okay, so let's find that 0. And we want to use the up and down arrows to move between the graphs. Alright, so our first 0 occurs there at 2.07. If you go down to f3, which is our second derivative, at that point the second derivative has a negative value. Okay, what does it mean if we have a negative second derivative? It means that it's concave down. So what has that shown us? That's shown us that by graphing the first derivative, finding the 0, and then checking the value of the second derivative, that we have a local maximum there, because it's concave down. Okay, back to the derivative. If we move along, okay, there's the next 0 at x equals 4.49. If we go to the black curve, it's positive, which means that we have a stationary point because the first derivative is 0, and it is a minimum, a relative minimum, because the second derivative is positive. Now, I don't particularly like this question here because I think that, you know, if you're going to find the relative extrema of that function, you're just going to find the turning points, right? The maximum and minimum of the original function. The second question, okay, we can also use that same method in order to find the global extrema between those values. Now, in terms of a global extrema, let's create a new graphs page. And the function is x plus sine of x squared. Okay, that's what it looks like. Pretty horrendous. But we want to limit it between 0 and pi, all right? And we want the global extrema. Global extreme points are for the whole function. Okay, so the most maximum point, the most minimum point. So we are looking at 0 to pi. So what I would do here is add in a relation. So go menu, graph entry, edit, relation. And I'd go x equals 0. Okay, and I would also go x equals pi. All right. What's the point of doing that? Well, what it shows us is that that point of intersection there okay, the point of intersection, which it's not going to show, let me actually find it. Analyze intersection of that and that. Drag, oops, click, drag out a region. Alright, there we go. Okay, there's my y value at that black point there. Obviously, the end point isn't the global maximum. The global minimum occurs here when x equals 0. So we have to find the actual points. So if we now go menu, trace, graph trace, alright, and if we look down here, that coordinate is 0, 0. That's the global minimum. As we move along, you have a local maximum or a relative maximum, but it isn't the most maximum point on the graph. You have a relative minimum, but it's not the most minimum point because this point here, 0, 0, was more minimum. And then here we have the global maximum. Within that range, domain between x equals 0 and x equals pi, that is the most maximum point. And so there's our coordinate, 2.83, 3.82.